Okay, so take a minute to log on to Canvas and like go to the quiz page, just so like once we once I finish, you could start the quiz immediately. So again, it's the discussion Canvas space, and then go to quiz tab. Is everyone good? Need more time? Yes, no. Do you all see it? Okay, cool, cool. Okay, let's get started then. Okay, so last time we learned about like area, yeah? So what we're gonna do is it's the area, it's like the area of a region, but then we're gonna reflect it about something to make it like volume. So let me just say, so there are like sort of like four cases, so I'll just go over all of it. So let's do the easy one. Y equals x squared. Let's just say from 0 to 1, yeah? So the area of this region is this, right? Now, if you, how did I explain this correctly? So if you take a point, if this is the x-axis, and you have a point here, right? And you want to rotate about x-axis. What what would the the rotation path look like? Like if I were to draw this, like what kind of shape would it look like? So like if I took this point and I sort of rotated about no just this point, just this point. Yeah, it would be a circle, yeah? Like I mean, it's not gonna touch the line because you're rotating it, right? It's like sticking a line through a circle. So now you can think of it like, so now this is for a single point, right? So here we're doing it for every point in this region. Yeah. So any point here, it makes like a circle. So the overall shape is you're going to get like a whole, like this point here would be the biggest circle. It would be like here, and then smaller and smaller, and then it would go, and then it would form a cone. Yeah. Does everyone agree with this? So think of rotating like every point. Yeah. There's like infinitely many, right? It's like the whole region, but you can sort of see it makes like the shape of a cone. Now I can ask, what's the volume of this cone? Now, what we're gonna do is we're gonna take like, uh, for volume, I need like, a three-dimensional thing, right? So this is two-dimensional, and then I'm gonna add like a little width to it. So we're gonna call that little, that little width like dx. So if I have like you know, something like this, it looks something like this, right? Like I guess it's circular on the bottom too. I'm really bad at drawing, but like, you think of it like this. It looks kind of like canned food, yeah. So how would you find like the volume, right? If I told you the base is the circle and the height is like dx. What's volume of like, you know, if I gave you a base and a height, what's the volume? Yeah, it's like basically area of the base times the height, right? In this case, area of the base, well, it's a circle. This is radius r. It's pi r squared times dx, right? Agree? So this one's the same thing, right? So we have dx for the height, and the radius. Well, the radius is, you know, draw a line from here to here. It's a circle, right? So the radius is obviously just x squared. So it's pi x squared squared. And this is for one little canned food, yeah? We're taking like canned foods and we're integrating from 0 to 1, yeah? Because I mean, this point's 1. So kind of like how in area, right? For area, we take rectangles and we integrate from like A to B. Well, for volume, we need to be like an extra dimension, right? So we take area and then we integrate from A to B, not just, you know. Everyone clear on this? Yes, no. So at this point, it's just, you know, you know how to do this, right? So at this point, it's just, you know, FTC. So this is what, it's nice because that 0 is 0. So pi over 5. Yeah. Does everyone follow with this? Now let's let me ask a question just so because I know this question comes up like every year. No, not every year. Every like Math 2B quarter. So let me draw this picture again. What does it look like this? Yeah. So you know how we took the circle here of like little height, you know, think of this as canned food, but I'm not going to draw the dx. But why do I not take like this radius, for example? Why do I take it? Would it matter? Is my question. Would it change the answer if I took a different line? Because I'm sure some people are going to ask why don't you take the bottom route, right? No, right? I mean a circle, right? A circle. If this is r, 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 right? Like it's a circle. Like it can't have like two different radius, right? Like a circle can only have like one fixed radius, so it doesn't matter where I draw the line. But my question is, why did I draw the line to the top? So again, the answer won't change. Yeah, exactly. Because we know this function, right? Like this thing, I know this is x squared. This thing is no longer x squared, right? So if you want, you could use this one, in which case you would have to figure out what this function is. Yeah, no, nobody gave it to you. In fact, this is the function you get when you reflect x squared by the x-axis. So if you remember like Math 2A, like the linear transformations from week 1, like what happens when you shift 2 units right, 3 units to the left, reflect about x-axis, reflect about y-axis. In this case, it's the thing you get when you reflect about the x-axis. So I'm saying you could use this, right? It's just you would have to find what this function is. And I mean, why would you ever do that if you already have this one right here? Like, I mean, unless you want to put more work on yourself. Yeah. Like, so, but if you do find what this function is, you will get the same answer. Yeah. Because I mean, like I said, a circle doesn't matter which way you go, right? It's R. It's R on like all directions. Okay. Everyone follow. Yes, no. So this part is called disk, rotate x-axis. Yeah, so this is the first case. This is called disk method, if you like. Method. So like if you ever want to look it up online, yeah, you just type disk method. Okay. So now let's do y-axis. Y-axis. Let's use a different function. So, all right, let me just say, for this one, right, where we integrate left to right, right? Right, we're going from 0 to 1. Yeah. So you can guess what happens when we rotate about y-axis. So let's use this function. So here is 1. I copy from the book, by the way. These are examples in the book. So this is y equals 9. Yeah, and they want this region. Let me just draw it here. And then we rotate region about y-axis. So what would this look like? Can anyone tell me? So if I take a point here and I rotate, sort of, because it's not flat, but, and I rotate, it's the same idea, right? Kind of like how I drew last time. When you take a point, you get a circle, right? Same thing here, except you're rotating about a vertical line now. So in this case, right, it's the same thing, right? You get, sorry, let me just write this as at 9. Okay. So at this point, you're gonna get the same thing, right? At this point, it gets rotated to the other side. Right? So it forms, this is like the biggest circle. And then it just goes, bad drawing. Yeah, and it just goes from here to here, right? Like this point gets rotated all the way here, so on and so forth, right? Do you all see this? So does everyone see this? Like, okay, good. And then same exact thing, right? Like I'm taking a canned food, canned food of with, in this case is dy. We name it dy. And we're doing dy because we're going bottom to top, right? We're taking canned food, the volume of like little canned foods, and then we're going bottom to top. Yeah. So in this case, it's obvious we start at 1 and at 9, right? And then what is the radius of this canned food? Good, but since we're doing dy, let's just solve for. What is this? Yeah, 1/3. So it's pi, this thing squared, right? So it's pi y minus 1 to the 2/3 dy. Yeah. So I guess your first question again, you could use this radius, right? But you would have to figure out what this function is, right? Because it's no longer x cubed plus 1. But so I'm saying you could use, dx, right? Like kind of like how for area of regions, I told you, right? Like, oh, I don't know why I drew that straight. Like you could do dx or dy, right? We did this, I mentioned it last time, right? It's your choice. But here, if you decided to use dx, you're gonna see how hard this is. I mean, ideally it's possible, right? You take circles like this and then you integrate left to right, right? Left to right. But I'm saying finding the radius of this circle is hard. Finding formula for radius is hard. Yeah. I mean, I'm sure we could all agree on that. The reason finding the radius and we integrate bottom top is easy is because it's symmetric about this thing, right? It's symmetric about the y-axis. So like it's easy because the radius, like the center, is just in the middle. It's where the y-axis is. Yeah, here it's I'm sure we could all agree it's kind of hard to figure out a formula for this in general, right? But if you could, then yeah, you could do dx. Everyone follow. So I mean, at this point, it's just you is. I trust you could do this. Pi u to the 2/3 du, and when y is 1, u is 0. When y is 9, u is 8, right? 5/3, I think, right? 3/5 evaluated at. So it should just be this, right? To the 5/3. Yeah, everyone good? So it's volume, right? Because if you think of if you're a unit person, right? This is like you're squaring. So if this thing is like centimeters, then this is centimeter squared times centimeter. So you get like centimeter cubed, as opposed to like area, right? If this was f, as integral f of x dx, this is centimeter, this is centimeter. So you get area. Yeah. Yeah, I'm gonna go back. Everyone follow. So this is simpler than what we're gonna go over next. Okay. So let's continue. So let's do something different. So next thing is let's do Washer's method. Yeah, it's called Washer's method. And let's do x-axis first, yeah? So this one is y equals 1/2 x, right? So you could check that they intersect at like 4, 2, 0, 0. Yeah. Okay. Now I want to reflect this region about the x-axis. So why is this different? So if I chose the whole cone, right? Let me just draw this really quick, right? That would be if I just took volume like I did before, right? Of like the, just the circle, the circle here, right? You see that that isn't really what we want, right? Because the point is, for example, this point right here certainly makes a circle, right? Do you all see this? But this whole cone or cone-like thing, right? Like these points also get, rotated. Do you all agree? But this point right here, the blue point, is not in my region. Do you all see that? Like I only want to like rotate the green stuff, right? Like not the blue stuff. But like this big cone includes the blue stuff. So you see in this case, we have to like exclude all the blue stuff that gets rotated. Yeah, in like easy terms. So what do we do? I hate this thing. How do I erase without erasing everything? Okay, anyway, let me just redraw. So, well, this thing would give me the whole if I just integrate this like this, it would give me the whole cone, right? Because I mean, I'm taking the most outer one, and then I want to exclude everything inside. Yeah. So I want to exclude everything that gets rotated inside. So you can see that at each point, right? I want volume of like this part, right? Do you all agree? So, I mean, at this point, it's just picture, right? So, so hopefully you can all agree it's area of green, or sorry, volume of green. At least the base, right? The base wise, it's area of green circle minus area of blue circle. Do you all see this? So you see, in this case, I mean, we're integrating 0 to what? This thing's 4? Yes, 4. Right? It's pi, the green circle gives, what's the outer one? Root x squared, right? And then and then the blue circle is pi 1/2 x squared dx. Yeah. So I'm guessing it's called washer because if you, I don't know if you ever like have a laundry machine. I think it looks like this, right? There's like I mean, inside like a circle, and then there's like a little circle on the, I mean, not a circle, but like the thing that sticks out where you like pour like the laundry detergent, like laundry soap. So I think that's where they get it from, like the kind of represents this picture right here. So yeah, so at this point, it's just integrating pi 1/4 x squared. Oh, what is this? Pi 12, right? 4 times 3. If I make algebra error, tell me. So this is what, 4 squared 16, 8 pi minus 64 over 12, right? Whatever that is. Yeah, so basically, if you're doing rotation to figure out if it's disc or washer, figure out if there are like any holes. Yeah. If basically when I rotate, does everything get rotated? Or are there stuff like in this case, like these points here, they don't get rotated, right? Because they're not part of the shaded region. Everyone follow. Yeah. Oh, really? I thought it was related to the washing machine. I mean, I don't know. That was my guess. So this, oh, by the way, someone asked me, this is part of, this is chapter 6. So this stuff went over Wednesday, but your quiz is on 5.4 or 5.5. So 5.4 is like what? Antiderivatives. So make sure you study everything about antiderivatives, right? That's like fundamental theorem of calculus, right? I think, or like net change theorem, yeah. And then 5.5 is U sub, I believe. So so basically, know how to do U sub. Okay. Yeah, so this is like chapter 6. Okay, let's do one more. So let's do the last one, right? Washer, y-axis. Let me read that. What is it? Little metal disc that you put in between a screw and a board. Oh, is that what it is? Okay. Okay, maybe it is that. Okay. So let's do the same region, but this time reflected about the y-axis, right? So if I do the same, again, this is the same thing, root x, 1/2 x, right? So again, do you all agree if I just rotated like everything, right? This thing would give me this shape right here. That's pretty bad drawing. Uh, so I would guess something like this, right? And then, right? Do you all agree? If this is my region. Now, same idea, right? Stuff here also gets rotated and it's inside my cone, yeah? I want to exclude those. So in this case, right, I would do this, right? It would, same idea, right? I want to exclude everything that gets rotated on the inside as opposed, take everything that gets rotated and then exclude everything that gets rotated on the inside, right? So you see here, my true radius is this thing, and then all the way to the end, right? So in this case, right, since this point is 4, 2, and this is 0, 0, I'm integrating bottom to top. So it's 0 to 2, and then this is dy. So pi, what's the outer thing? If you like, you could do outer minus inner, right? So the bigger one's the blue circle. So this one is the blue circle, the radius is 1/2 x, right? So y equals 1/2 x. X is 2y, yeah? 2y squared. And then minus pi. What's the green circle? The green circle is the root x, right? So x is y squared. So 4y squared minus y to the 4th dy, and it is whatever this is, right? So what is that? 4 pi y cubed over 3 minus y to the 5th over 5. So 12 pi, actually, not 12. 2 cubed is 8, 32. Yeah, should be 32. Minus 32 over, whoa, where did my pi go? That was weird. So 32 over 5 pi. Everyone see this? So it's really, just it's so again, if it's disk, then it's just pi whatever squared. If it's washer, if you have holes, then it's think of it like outer minus inner. Yeah. So for this example, right, like if instead my region was this whole thing here, then it would be washer, right? It would be the whole cone. Do you all agree? Because every point gets rotated. Yeah. Hopefully you all see that. But we were only doing the region like here. Does everyone understand volume or have any questions? Yeah, circles are simpler. Exactly. Uh, you could, right? But because you're rotating, right? It's natural to use circle because if I rotate something, it makes a circle. The shape it makes is a circle already. So like it's natural to use like circles because we're rotating, right? Like the formula would be very easy as opposed to if you use like a square or something. Yeah. Uh, okay, you have like 3 minutes to like self-study. No, you if you use other shape, you should get the same answer. I'm just saying it's hard to find the formula for it, right? Like if I'm using like you know so here, right? Like if I'm like using like if I'm estimating through like squares, right? It would be like a square, it would be like a rectangular prism, right? Something like this sort of, right? In which case you would have to find a formula for the width, the the this thing, and then I mean the height is just the height would be like dx, but I mean in this case dy. But you would have to find you would have to find a formula for the green and red, right? Which is I don't think that's very I think that's pretty hard. Okay, so you can okay you could maybe turn on your cameras and then